Solve this horrible, ugly-looking equation. This looks pretty bad, but let me point out something that's really nice. We know that we like factoring. If our variable shows up multiple times, factoring is the way to go. And notice that this kind of looks like I've got this weird root 3 over 2 in these two different places. Notice that if I group this, okay, then this first group, I can factor out a sine of 2x. Factor a sine of 2x. And that leaves us with a sine of 2x minus a square root of 3 over 2. And then I've got plus, and this thing right here is that exact thing. I'm just going to go ahead and put it in parentheses so that we see that it's the same. So we can then actually factor this sine of 2x minus root 3 over 2 out completely. So I have sine 2x minus root 3 over 2. Okay, I'm factoring that out, and I'm left with a sine of 2x, and then plus 1. All right, so this is my factored form, and now that lets me to break this up into two different pieces. So this first one, I've got sine of 2x minus root 3 over 2 is equal to 0. And then the second one, I've got sine of 2x plus 1 is equal to 0. All right, so now let's go from there. If I add root 3 over 2 here, I get sine of 2x plus the square root of 3 over 2. I'm sorry, not plus, that's ridiculous. Equals the square root of 3 over 2. Over here, if I subtract 1, I have sine of 2x equals negative 1. All right, then I need to get rid of this sine. Okay, so I need to know when is the sine equal to square root of 3 over 2. Now, what's important here is we are given here a domain for x. X has to be between 0 and 360 degrees. So, but the angle here is actually 2x. So what I'm going to do is say, well, if I have this, that tells me that 2x is actually between 0 and 720 degrees. Okay, that's important to note because I want to know when is the sine of something between 0 and 720 degrees equal to root 3 over 2. So let's go ahead and do that. In our unit circle, that's nice and very sloppy, my sine is root 3 over 2 up here and up here. Okay, so those spots, I need to write what those spots are, all the values between 0 and 720 degrees. So this first one is at 60 degrees. The second one is at 120 degrees. And then I go all the way around, okay, and that's this spot here. That's just going to be 60 degrees plus 360, which is 420. And then this one here, if I go all the way around, come to that, that's just 120 plus 360, which is 408. So I get 4 places where the sine of 2x is equal to root 3 over 2. But also over here, I care about when sine of 2x is equal to negative 1. And negative 1, that's down here. Okay, so, well, that's right here. Of course, that's at 3 pi over 2, or in degrees, that's 270 degrees. But we could also go all the way around there. One more revolution, or just add 360 degrees to this, and we'd get, oh, now I'm blanking. Add 360 to this, and we get 630. 630. Okay, so those are all of the angles, 2x between 0 and 720, where we get either one of these. Now I can divide by 2 to get my solutions for x. So to just divide each of these by 2. 60 divided by 2, 30 degrees. 120 over 2 is 60. 420 over 2 is 210. 480 over 2 is 240. 270 over 2 is 135. And 630 over 2 is 3. Note that all of these angles are between 0 and 360 degrees. So those are all of our solutions for this equation.